So section 6.1, we decided to break up into two parts about logarithmic and exponential equations. So let's get started. So friendly reminder that for all real numbers y and all positive numbers a and x, where a doesn't equal 1, right, our base has to be a positive number not equal to 1, and we'll talk more about that why that is later on in this section. I have y equals log base a of x is equivalent to x equals a to the y. So for example, if I had 3 equals log base 2 of 8, that means that 8 is 2, my base, cubed. So we have, by now, by this section at least, should be pretty comfortable switching back and forth between logarithms and exponential equations. So in order to solve some logarithmic equations, we can rewrite them as exponents. So for example, instead of having log base 3 of 3 to the negative 1 equals 2, this could be rewritten as 3 squared equals 3x minus 1. So I have 9 equals 3x minus 1. I can then go ahead and add 1 to both sides. That gives me a little more room. 10 equals 3x. Divide both sides by 3. X equals 10 thirds. Let's go ahead and solve this logarithmic expression. If I have log base 2 of x equals 4, that means that 2 to the 4th equals x. So 2 to the 4th is going to give us 16. So 16 equals x. For example 3, we need to remember everything we possibly can about absolute value. Friendly reminder, absolute value is a measure of distance on the number line from the origin. So whether you have negative 3 or positive 3, they both have an absolute value of 3 because they are both 3 from the origin. So now I have 4 cubed equals the absolute value of x. So I have 64 is the absolute value of x. So here, what two values of x could I substitute in order to get 64? Well, that's going to be 64 and negative 64. Another logarithm rule that we have is log base a of m equals log base a of n. If I have that, then m equals n. So here I have log base 5 of 2x plus 11 equals log base 5 of 3. That means that 2x plus 11 equals 3. So I can go ahead and solve for x, right? This is a lot easier than having to deal with logarithms. I'm going to go ahead and subtract 11 from both sides. I get 2x equals negative 8. So x is going to be negative 4. Let's take a look at example 2. I have log base 4 of the absolute value of 3x plus 4 equals log base 4 of the absolute value of 5x minus 12. So I need to keep in mind our rules for solving absolute value equations. I'm going to take both of them to be positive, and then I'm going to take one of them to be negative. That's the rule. Now, I don't want them both to be negative, because if I had made them both negative, well, the negative would cancel out, right? And so I'd be left with 2 negatives, which gives me 2 positives, the same as what we have here on the left. And if I didn't want to make my equation on the right negative, I could have done it to the equation on the left too, right? If I divide both sides by negative 1, you'd see my negative would move over here. So that's why we set up those equations this way. So I'm going to go ahead and solve my equation on the left first. I'm going to subtract 5x from both sides. Apparently I'm also going to change pen color. That gives me negative 2x. I'm going to subtract 4 from both sides. I have negative 2x equals negative 16. That gives me x equals a positive 8. Now I have to determine my other x value. I have 3x plus 4 equals negative 5x minus 12. I add 5x to both sides. That gives me 8x plus 4 equals negative 12. I go ahead and subtract 4 from both sides. I get 8x equals negative 16. Okay, so I have x equals negative 2. Now, I need to check to see if both of these are solutions. Here's something we're talking about later on in this section that I haven't brought up already. But it's you cannot take the logarithm of negative numbers. Now we're really lucky because in both these cases, if we plug in a positive number, we're always going to have a positive. If we plug in a negative number, we're always going to have a positive because we're taking the absolute value. So we don't have to worry about this in this case, but it's just something I wanted to bring up so we have it in mind as we continue through this section. Our final example, I'm going to switch to orange because that's a happy color. I have 3 log base 2 of x equals negative log base 2 of 27. So what I'm going to have to do, though, in order to get these in the same log base a of m form is I'm going to have to take these constants and turn them back into exponents. Remember, that's one of our rules for logarithms is if I have an exponent, I can move it to the front. So now I have log base 2, I spelled log really funny, log base 2 of x cubed equals log base 2 of 27 to the negative 1. That means x cubed equals 27 to the negative 1. So x cubed equals 1 over 27, which means I take the cube root of both sides. So I get that x equals 1/3. Final answer. When we're solving exponential equations, if I have the same base raised to 2 different powers, we can set those equal to each other. So if I have a to the u equals a to the v, then u equals v. So if I have 2 to the negative x equals 16, the problem is that both of these don't have the same base. So I'm going to have to rewrite 2. I'm going to have to rewrite 16, sorry, to have a base 2. That'd be 2 to the 4th. So I have that negative x equals 4. That gives me x equals negative 4. If I have 3 to the 2x minus 5 equals 9, I'm going to rewrite this as 3 to the 2x minus 5 equals 3 squared. So I have that 2x minus 5 equals 2 by our theorem. I guess you could kind of call this a theorem. I'm going to add 5 to both sides. I get 2x equals 7, so x equals 7 halves. I'm going to go ahead and switch colors for clarification for these final 2 problems. If I have e to the 2x equals e to the 5x plus 2, that means I'm going to have 2x equals 5x plus 2 because e is our base. I subtract 5x from both sides. I get negative 3x equals 2. This is going to give me that x equals negative 2/3. For our last example, e to the x squared equals e to the x times 1 over e squared. I need to make these so they both have the same base, okay? So I'm going to have to rewrite our left-hand side as e to the 3x times e to the negative 2, right? That gets it out of the denominator into the same base. And then remember, when we're multiplying exponents, we add their powers. So I have e to the x squared equals e to the 3x minus 2. Now I can set these equal to each other. So I have x squared equals 3x minus 2. I'm going to subtract 3x and add 2 to both sides because I see here I've got a quadratic equation. So what I want to do is I want to find the factors of AC that add up to b. So what are some factors of 2 that add up to negative 3? Well, that'd be negative 1 and negative 2. So I set both these equal to 0. And I get that x equals 1 and x equals 2.